tricky and is kind of a curveball. When you're doing sequences and you're writing the general rule to go from in to out, so the nth term, it's not, you're using this +3 pattern as a clue for this, the function rule. So if I were to just take, well, +3 is the pattern. 1 plus 3 would be 4, and then 2 plus 3 would be 5, and 3 plus 3 would be 6. So we know that it's not actually +3. It has to be something else. So think of it in a different way. If I am doing +3 plus 3 plus 3, and it's that repeated addition, what am I in essence doing? Well, you're skip counting by threes. And another way to think of skip counting by threes is multiplying by 3, right? So this is going through the multiples of 3. So what if instead of saying +3, what if it were to be times 3? So to go from this input to this output times 3, and then how much would I need to shift it to then hit that target amount? So 1 times 3, I'm now at 3, but my output is 0. So how do I go from 3 to 0? Well, I subtract. So again, this is a two-part rule. So it could be times 3 minus 3. Let's go ahead and continue to check it. Input is 2, multiply by 3 is 6, minus 3 is 3. I think I'm onto something. 3 times 3 is 9, minus 3 is 6. 4 times 3 is 12, minus 3 is 9. Okay, so I think I have the rule. My rule to go from input to output is 3n minus 3. Okay, so I can put that here. Remember, your rule or your function is how do you get from the input to the output. This along the side, like how the pattern is growing, is a clue for what that input-output rule is, but it is not necessarily the rule. This +3 is what you call the term-to-term rule. So I'll put that over here. Term-to-term rule. And that's going to be a hint for your function, but it is not the function itself. Okay, so what do you do for your generalized step? Well, we already kind of did it. Basically, what you're doing, you're going to use your annotations to find the rule to go from in to out. And you write it as a function to be used for any term in the pattern. Okay, so back to this whole n nonsense. You're basically saying n is like any term in the sequence. So just like it could be anything. You use that as the placeholder variable, and then you can say, well, what would then the 10th number in the sequence be? So then you would substitute that in for n. 3 times 10 would be 30, minus 3 is 27. So you know the output of that sequence would be 27. What if n were to be, what is the 100th term in the sequence? Well, then you would plug that in for n being the variable that you use for your term number. 3 times 100 is 300, minus 3, that would be 297. So once you get the rule for the nth term, you can use it to apply to any term in the sequence. All right, so that's about it for sequences and patterns, and we will continue to work on this in class.